Have you ever stopped to think, what really goes into those super specialized, really critical jobs? The ones holding up so much of, well, our modern world.
Hmm.
Roles where you need this deep grasp of complex systems, the latest tech, and just incredible practical skill, not just nice to have, but the actual foundation.
Absolutely. Foundational is the right word.
Today, we're doing a deep dive into one of those fields, petroleum engineering. We're looking at a guide from Kaplan. It focuses on the key interview questions for these roles.
A good source for this kind of technical field.
Exactly. And our mission, for you listening, is to pull out the most important insights. Not just if you're looking for a job, but really for anyone who's curious about what it takes, skill-wise, in this vital industry. Okay, let's unpack this.
Yeah, it's a great topic. Because the petroleum engineer role, it's genuinely crucial, especially now with the energy sector changing so fast.
Revolving, yeah.
Yeah, these are the people applying expertise, not just in the traditional finding and producing oil and gas. Increasingly, they're the ones figuring out sustainable practices, trying to meet environmental standards.
That's a key shift.
It is. And because it's so technical, so specialized, you really need to understand the practical skills, the theory behind it, and importantly, the kind of problem solving they need day to day. It's a demanding job.
Right. So like any big project, you need that solid base. And in this field, it seems like that base is actual hands-on experience.
Hmm.
The Kaplan guide jumps right in with, what experience do you have in the oil and gas industry? Why
Yeah.
start there? What does that question really get at?
Well, it's fundamental because it cuts straight to whether someone's actually done the work, moved past the textbook.
Real world stuff.
Exactly. And a good answer, according to the guide, isn't just I worked for X years or mentioning project names like Y and Z. It's showing you can take that academic knowledge and get real results.
Oh, okay. Application.
Yes. It shows you've got a solid handle on the core stuff, drilling techniques, how you actually make the holes, reservoir analysis, figuring out what's down there, how much, how it behaves, and production operations getting it out efficiently.
So the whole process.
Pretty much. It shows that mix of practical know-how and sharp thinking that's just essential. And that's also key for figuring out those greener, more sustainable methods later on.
Okay. So once you've got that experience foundation, the next layer seems to be about the tools, the digital side. The guide asks, can you explain your experience with reservoir simulation software? That sounds technical, like the digital command center.
Huh. Yeah, you could call it that. It's really the analytical heart for these engineers. This software lets them model, predict how underground reservoirs will behave.
See underground, basically.
In a way, yes. See what's happening miles down without physically going there.
Yeah.
The Kaplan guide mentions specific software names like Eclipse, PETREL, VIP. These are like the industry standards. And it also points out the difference between black oil and compositional simulations. Think of it like different map scales. Black oil is the big picture fluid flow. Compositional zooms right in down to the molecules.
Which matters for complex geology.
Exactly. Crucial for unconventional reservoirs where every little molecule's behavior counts. And these tools aren't just internal things, they're vital for forecasting, for optimization studies. They help make the big strategic decisions.
Like how much oil is really there? How fast can we get it?
Precisely. Which, feeds into global energy planning.
Yeah.
Decisions that ultimately affect all of us.
Fascinating how models predict the future like that. And speaking of the future, things change so fast in tech, right? Staying current can't just be optional. So the next question is key. How do you stay current on industry developments and advancements in technology?
Oh, absolutely. In energy, standing still means falling behind, fast. Continuous learning isn't just nice, it's survival. The source lists specific ways, reading trade journals, going to conferences and seminars. You learn a lot just talking to people there.
Networking and learning.
Definitely. Joining professional groups like the Society of Petroleum Engineers, SPE, is huge for that. And just constantly researching new tech, new methods.
So it shows dedication, adaptability.
Both. It shows you're committed and that you can pivot when the industry does, which it does, constantly.
Okay, so from the digital models and constant learning, let's get back to the physical side. Extracting the stuff, the guide kind of groups the next two. What is your experience with drilling operations? And then can you explain your experience with well completion and production? This feels like the whole journey, concept to pump.
That's a good way to put it. Yeah, these cover the physical life cycle. Drilling is first, obviously. The source mentions things like well design, managing drilling fluids, that's critical, like getting the chemistry just right for the conditions downhole.
High stakes chemistry.
Very high stakes. Also, well control. Those are the safety procedures to prevent blowouts. Hugely important. Plus, managing the teams, knowing the safety rules inside out.
Okay, that's drilling. What about completion?
Right, completion is prepping the well. Think perforation, making holes in the casing so oil or gas can flow in, sand control if needed, and artificial lift methods to help get fluids to the surface if the natural pressure isn't enough.
Like giving the well a boost.
Sort of, yeah. It's like setting up the plumbing for this incredibly deep, high-pressure system. Then comes production. Testing the well, logging its performance, optimizing those lift systems over time. It's a really broad skill set needed theory and tough practical work.
It sounds incredibly comprehensive. So all these different skills, drilling, modeling, geology, learning, they all have to come together when things go wrong or just need figuring out. Which brings us to the last question Kaplan highlights. What is your approach to problem solving? How do they tackle the really hard puzzles?
Yeah, this one gets to the core of being an engineer, doesn't it? The source lays out a pretty systematic approach. First step, gather all the data you can. You can't fix what you don't understand, especially with such complex systems.
Makes sense. Get the facts.
Then use your critical thinking, your technical knowledge, analyze everything, brainstorm potential solution.
The what ifs.
Exactly. And then this is key way, the pros and cons of each what if. Often under pressure, maybe without all the info you wish you had.
Tough calls.
Definitely. And finally, make the decision. Pick the best path forward based on the analysis. What's insightful here is that problem solving in this field isn't just theoretical. Decisions have massive financial, environmental, safety consequences. It's very real world.
Wow. So stepping back, this whole dive into the Kaplan questions, it really paints a picture, doesn't it? The incredible range of skills needed. We've gone from that basic industry experience to mastering complex software like Eclipse, the need to constantly learn, the nitty-gritty of drilling and production, and finally, that structured, adaptable way of solving problems. Understanding all that really gives you, the listener, a deeper appreciation for just how demanding and innovative this field is.
Absolutely. And these questions, as the source suggests, they're designed precisely to check for those critical abilities needed to succeed in a really tough profession. It emphasizes that knowing stuff isn't enough. It's about applying it effectively in complex, often high-pressure situations.
The real-world application again.
Right. It really makes you think about how all these specialized pieces, this deep knowledge, actually drives such a massive global industry.
So a final thought for everyone listening, building on that idea of a changing energy world.
Yeah, thinking ahead. Given those ongoing shifts in global energy, if you were the one writing the next batch of interview questions for petroleum engineers, what new or emerging skills, maybe beyond what we talked about today, do you think would be absolutely essential? What comes next?